Okay, here we are, part 4. Find the values of A and B in the similar figures shown below. Again, there's no similarity, so keep moving. And so here we're going to have the relationship of 8 to 6.4. It's going to be the same as 7 to A, which is going to be the same as 6 to B. So let's start here. The decimals on this are going to drive me nuts. So 6.4 times 7. It ends up, so we have 7 times 6.4 equals 8a. Divide both sides by 8. 6.4 divided by 8 is going to be 0.8. So we have 7 times 0.8 equals a, which is 5.6 equals a. Then we have 8 over 6.4 equals 6 over b. That gives us 6 times 6.4 equals 8b. Divide both sides by 8. So keep in mind that 64 divided by 8 is 8. So 6.4 divided by 8 is going to be 0.8. That gives me 6 times 0.8 equals b, or 4.8. Triangle ABC has vertices of 3, 1, 1, 4, and 5, 3. Triangle ADE has vertices of ADE. Prove that ABC is similar to ADE using the distance formula. What postulate can you use to prove similarity? So this is going to be side, side, side. Okay, let's do this again. So we have ABC. So we have 3 sides. We have AB, which is 3, 1 to 1, 4. We have BC, which is 1, 4 to 5, 3. And we have CD, or CA, sorry, which is 3, 1 to 5, 3. So I'm not going to talk through this, just follow along. This is my x1, y1, this is my x2, y2. So apparently I am going to talk through this. So this turns into 1 minus 3 squared plus 4 minus 1 squared, which gives me the square root of negative 2 squared plus 3 squared, which gives me the square root of 4 plus 9, or the square root of 13. This is going to give me the square root of 5 minus 1 squared plus 3 minus 4 squared, which is going to be the square root of 4 squared plus negative 1 squared, which is going to be the square root of 16 plus 1, or the square root of 17. This right here is going to give the square root of 5 minus 3 squared plus 3 minus 1 squared, which is going to give me the square root of 2 squared plus 2 squared, which is the square root of 4 plus 4, which is the square root of 8, which is the 2 radical 2. Okay. So what I'm going to look at are these right here. So now what we're going to do is we're going to do ADE. So we have A to D, D to E, and A to E. So this is going to be 3, 1, negative 1, 7. This is going to be negative 1, 7, and 7, 5. This is going to be 3, 1, and 7, 5. Okay. Again, so this is going to give us negative 1 minus 3 squared plus 7 minus 1 squared. It's going to give us negative 4 squared plus 8 squared, there's 6 squared, sorry, which is going to give me the square root of It's going to give me the square root of 16 plus 36 or the square root of 52. So notice that from 13 to 52, that's a times 4. So that's what I'm going to be looking for here, is I'm going to be looking for each one of these second ones to be 4 times bigger, to have that same scale factor. So here we go, 7 minus a negative 1 squared plus 5 minus 7 squared is going to give me 8 squared plus negative 2 squared. It's going to give me the square root of 64 plus 4, or the square root of 68. 17 times 4, 68. So there we go, times 4. Here we go, 7 minus 3 squared plus 5 minus 1 squared gives me the square root of 4 squared plus 4 squared. So the square root of 16 plus 16, the square root of 32, or that would be 4 radical 2. 8 times 4 is 32. So notice that each one of these is four times bigger than the other one. So that's how we prove side-side-side similarity, because we were able to prove that each one of these is 4 times bigger. Okay. So I'm going to do some erasing now. Sound effects help. Don't let anyone tell you otherwise. So notice here that find the value of x in the image below. Don't get caught off here, guys. Notice that here, right here, that's 12. So don't go the relationship of 4 to 8 is 9 to x. Because if you go 8 to 4 equals 9 to x, you're going to end up with x equaling 4.5. And that's wrong. What we want to do is go the relationship of 8 to 4, or 2 to 1, equals the relationship not 8 to 4 at all. It's 12 to 4, which is 3 to 1, is 9 to x. Cross multiply, we get 9 equals 3x, or x equals 3. Okay, so a telephone pole 10 meters tall, boop, it's 10. Cast a shadow that is 8 meters long, 8, boom. At the same time, a nearby tree casts a shadow that is 14 meters long. How tall is it? So this is going to be similarity, so we're going to go the relationship between 14 over 8 equals the relationship between 10 over x. That gives me 14x equals 80. Divide both sides by 14, and we get x equals, geez, what is that? That's 20 divided by 7. That's wrong. 14 over 8 equals x over 10. I'm like, I'm doing something wrong. X over 10. So that gives me 140 equals 8x. Divide both sides by 8. And we get x equals 17.5. Okay. Everyone, okay, what are the measures of angles 1, 2, 3, and 4? So again, we're just playing around here with isosceles triangles. So if this right here is 50, we know that these two have to be equal because they're isosceles triangles. So 180 minus 50 is 130. We know that both of these have to be the same amount, so we do 130 divided by 2, and we get 65 for those. If this is 40, this is 40. 40 and 40 is 80, so that's 100 right there. Here, again, isosceles triangles, we know those are equal. So we go 2x minus 9 equals x plus 5. We're going to subtract x. We're going to get x minus 9 equals 5. We're going to add 9. We get x equals 14. And this is an isosceles triangle. 21. 100 equals 2x plus 3x. Divide by 5. X equals 20. Hey Google, how windy is it outside?
In Cottonwood, the wind is currently from the southwest at 21 miles per hour.
It says 21 miles an hour. I'm going to call BS on that and say it's a lot more. Anyway. Okay, so this is a similarity problem. So skip it unless you're in honors. So is line QS parallel to PT? So if this is parallel, then we know that these are going to be proportionate. So we can go 10 to 4 equals 16.5 over 6.5. So when we cross multiply, if we get the same answer for both of them, we know they're parallel. If not, we know they're not. So we're going to go 10 times 6.5 equals 4 times 16.5. That gives me 65 equals, do a little math over here, we're going to go 16.5 times 4. That is 0, 2, 20, 24, 25, 26. And we get 66. So no, they are not equal. So no. Sides not proportionate. (23) What value of x would make line BD parallel? So now we go 12 over x equals 16 over 4. So 16 over 4 I know reduces to 4 over 1. So we go 12x equals 4 over 1. Make my math a little bit easier. Cross multiply. That gives me 12 equals 4x, or x equals 3. Again, that's a similarity problem. Centroid. So if r to p is 10, find the length of r to t. Remember that the centroid, that right there, that is 2/3 of the distance from the vertex to the midpoint, which means that this is 5 right here, because that's 1/3. It's going to be half. 10 plus 5, 15. N is the centroid of JKL and KM right here. So the whole thing is 36. What is the length of M to N? So we know that that is going to be 1/3 of this. We go 36 divided by 3 equals 12. What is the measure of angle 1? We know that these two added together equal angle 1, so that's going to be 125. In each figure below, prove whether line AE is parallel to line BD. Again, what we're looking for is proportionality. So we go, is 9 to 6 equal to 3 to 2? Yes. We cross multiply and we get 18 equals 18. Here we cross multiply, we get 3 over 1 equals 4 over 2. So cross multiply, we get 6 equals 4. That's a no. Here, 9 over 7 equals 3 over 2. Cross multiply, we get 18 equals 21. That's a no. Here we have 10 over 6 equals 5 over 3. Cross multiply, we get 30 equals 30. That's a yes. (28) What would the dilation coordinates of image A be? Holy crap. Wind is ferocious. My backyard's going to be a mess tomorrow. Well, my backyard's probably a mess right now. I just won't actually see it because it's dark. So, a dilation with a scale factor of 2.5. So this is everybody. Dilations, we all know how to do this. So it's from the center. So what we're going to do is we're going to take 2.5 and we're going to multiply it by everything. So the coordinates of image A. So we just need A right there. Oh wait, image A. I don't like that they have point A for image A. Anyway, A prime, 3 times 2.5 would be 7.5. 5 times 2.5 would be 12.5. B prime, 4 times 2.5 would be 10. 5 times 2, or 2 times 2.5, because we're doing each one of these times 2.5 times 2.5. That's going to give me here and there. Times 2.5, 10. Times 2.5, 5. And then C prime is going to be 2.5, 2.5. Just because I multiply both of those by 2.5, multiply one by anything and you get the same thing. So that was number 28. How many are there here? Oh, last page. I'm going to stop this so I don't have to redo all that. And I'll see you all on part, 5 probably?